Now, next example 3, find I naught by using superposition in the circuit. So this time we are going to find a current instead of voltage. So 3 independent sources in the circuit, and we obviously gonna split them into 3 individual circuits. So let's see what's new we can learn out of this example. So here's the solution. 3 circuits are here, here, and here. Keep 12 volts here. Make the rest of 2 current sources 0 and 0. Here, keep this 6 milli. Make the voltage source and current source 0. In this circuit, we keep 2 milliampere here and get rid of the rest of 2. Let me know if you have any questions to reach this step 1. Okay? Based on which, we move forward to respectively find, obviously, I naught prime, I naught double prime, and I naught triple prime here. So again, feel free to apply nodal or mesh as long as you feel comfortable with. But here, to teach more to learn, I would like to solve the circuit by simply combining the resistance, which is sometimes more difficult and complicated. Let's see the first circuit here. So we have a voltage source here and feeding 3 resistors. If you observe carefully, so 2K here and 4K here, they are series connected. And then as one branch, parallel with 6K up here. So this is not a voltage divider since this branch and this 6K are parallel, having the exactly same voltage, which is nothing but the source voltage 12 volts. So how to find the current through this 2 kilo ohm? I just simply apply Ohm's law. Okay. Total voltage 12 volts divided by the 2K plus 4K equals to the current flow through this branch. However, according to the voltage source polarity here, the introduced current through this branch is downward through 4 kilo ohm and upward through 2 kilo ohm, which is opposite to the I naught prime we are looking for. That's why we must apply a negative sign in front of it. So I naught prime in the first circuit is equal to negative 2 milliampere. Let's take a look at the second circuit here. It's actually even trickier. Look at the circuit up here. So the current 6 milliampere flow downward and then towards right through 2 kilo ohm, no problem. And then keep going downwards right through 4 kilo ohm, no problem as well. However, the tricky thing is this current reach this node and then do what? This is so-called short out. What I'm saying is the current reaching this node and then it's gonna flow through this short circuit here and then go back without flowing through this 2K and the 4K at all. Therefore, the I naught double prime is 0 current. Once again, this is so-called short out. This short circuit parallel with this 2K and 4K, therefore it is shorting out them. No current through. And this is one of the basic characteristics of the current. It always flows through the minimum resistance path. The short circuit is obviously technically the minimum. Third one here, you can tell 4K and the 2K here, they are parallel. So is these two up here. And then these two parallel are series connected. So this is not a current divider because series connected elements sharing the same current, which is exactly the given source current, 2 milli. Therefore, the current flow through this parallel is equals to 2 milli. If I call it Ix equals to 2 milli downwards. And how to find I naught triple prime? Here, I'm applying a current divider because, again, we said the total current through these two parallel is equals to Ix, 2 milliampere. Then what is the current flow through one of the branches here then? Downwards. This is nothing but the current divider. total 2 milli shared by two parallel branches, 2 kilo and 4 kilo. And then find the current through 2 kilo is equal to 4/3 milliampere is the answer for I naught triple prime. The last step is very straightforward, and you just need to sum them up to end up with total I naught we're looking for. Turned out to be negative 2/3 milliampere. Now let's talk about the very last example, example 4. So find two currents Ix and Iy labeled in the circuit by using superposition. So we are seeing this time one independent voltage source, one independent current source, we can take care. And also one dependent voltage source and one dependent current source. So very good example including all kinds of sources. So if you recall the previous slide, we said dependent sources are so-called untouchable. So let's see how we should deal with them. So here's the solution. As first step, we split the original circuit into two easier circuits. Here, be careful, we are splitting them based on independent sources rather than dependent sources. This is why we call it untouchable. So in the first circuit, we are keeping the independent voltage source here and open the independent current source here, since this is current source. In the second circuit, we keep the independent current source and short the independent voltage source. And then to the first circuit is actually a tricky circuit, and here's the solution. We can tell in the entire circuit, actually, there's no closed loop for this independent voltage source, who is the only source feeding the rest of the circuit. Therefore, there's no current. No matter what we are looking for, it's basically zero. So the Ix and Iy prime, they are all zero. To see this more clear, you can try to drag these parts of the circuit and this part of the circuit away towards two different directions. And then what you're seeing is kind of one line without loop closed. Therefore, it makes sense. There's nothing going on in this circuit at all. To the second circuit here, obviously, due to the presence of dependent sources, the best solution is mesh or nodal. Since they have no constraints, they can deal with any kind of circuit. So don't think of voltage or current divider. They won't work for dependent sources. Okay? So here, I'm using the nodal and picking the top nodal here with a super node and the bottom node here to write two KCLs here and here. And also you need to be able to realize that the current down here, Iy, going through 1 ohm is equals to Ohm's law. Voltage cross it, divide by 1. And what is the voltage cross 1 ohm with this polarity? It's nothing but this 6Ix. Since this dependent voltage source is parallel with 1 ohm. So the voltage source voltage value is equal to the voltage cross this 1 ohm. Iy equals to voltage divided by resistance, okay, as the third equation. Another thing I want to remind you is the bottom node here is not necessarily the ground, which we generally don't pick to write KCL for. The reason is very simple. You have a current source down here. So you either pick this node to write KCL or pick this node to write KCL. Because one of them is ground, the other is definitely not. Okay, so 3 equations, 3 unknowns can do the job. Find pretty much Ix and Iy double prime. Of course, at last, the Ix and Iy we are looking for, they're equal just to sum up the first circuit result and the second circuit result. Turn out to be -1 ampere and -6 ampere respectively. Okay, so that's all about this module, and the key is, once again, practice yourself independently and bring up the questions in the conference. And also feel free to send me your solution to let me judge if it is right or wrong and why it is right, why it is wrong. Okay. Thank you and see you in the next module.